In this video, we're going to look at AP Practice Problem 10. AP Practice Problem 10 is basically just a full-out hypothesis test. Now, chances are on this exam, they're not going to ask a full-out hypothesis test. It would basically take up all your time on a question. But it's good to go over a full hypothesis test again, since it's something that you probably haven't done in a while, if you did it at all. Like I said, depends on what level of work you've been doing. But the concepts, basically doing one out has all the concepts of one in it. So if they focus on different parts, if you can do the whole thing, you shouldn't have a problem answering questions with parts. So the context for this problem is that they do a survey, and they do, it's basically a survey of this question: do you think television commercials are effective to promote new products? They ask a certain number of people in 2008. And they also they had asked a certain number of people in 2007. So they give you basically the proportions of people that say each thing. So hint, this is going to be, there's two proportions, so it's going to be a two proportion z-test. So that's what you should get out of this. So look, they're giving me two sets of proportions. Basically, you can figure out what the proportions are, because the 2008 survey had 1,009 people, 676 said yes, and I said it's categorical data, so basically it's yes or no. That's the number that said yes, the rest said no. And then in 2007, the year before, it was 622 out of 1020. So they basically want to know, is this indicative of a change in people's opinions? So the proportions are a little different. Like I said, the number they took people out of is a little different, but overall the December 2007 one has only 622 out of 1020. The next year, the 622 goes up to 676, and the denominator goes down to 2009. So the 2008 one has a higher proportion of people. So in the survey, it looks like 2008 is higher. So you would then go, oh, well, 2008 is better. But remember, there's natural variation involved. They could come from the same population, and you just got a little bit less due to natural variation. So this is why the test is necessary, because they say, do these samples provide convincing evidence that in the population, people actually changed what they thought from 2007 to 2008? The samples are different, but what does that say about the population? So when we do a two proportion test, our assumption is always that the population actually has no difference. We're assuming the reason we see this is that it's natural variation. If we come out with a low p-value, we then reverse our thinking, go, okay, well, these are so significantly different that it's probably due to the population. All right, so let's go through the entire test. First, you should define your terms. They do allow you, if you say p sub 07, p sub 08, they allow that, and you don't have to describe what they are. But I would be safe and describe them anyway. So I described P sub 07 as a proportion of adults in the U.S. who answered yes to the commercial effectiveness in 2007. And then same thing for P08, the proportion of adults. I didn't write out the whole thing, but you're taking the test, do what you got to do. All right, they probably won't make you write something like this out, but at least, know what they're talking about. So P08 is the people who answered yes in 2008. So now where are my hypotheses? Well, my null hypothesis is always in a two sample or two proportion test. When there's two things, I'm always assuming that there is no difference between them. So you could say this is equal to this one, or that they subtract to be zero. They are the same. My alternative hypothesis is, now they don't ask if one's greater than the other, they just want to know if they're different. So that if you subtract them, it doesn't come out as zero, meaning that one of these is bigger than the other. You could also write that this is not equal to this. Depends on how you want to write it. All right, so there's my null. My null is that there is no difference. That's my assumption. And then I'll test and see, well, could it be that this isn't the case? Maybe it's this. All right, so that's part one. Part two is then to do the conditions check. Now, you should write these out if someone asks you to write out a condition. Basically, random, I believe they say it's random. Independent, why do I think it's independent? Well, is there any reason when I ask someone about commercial effectiveness that the next person would be biased by their answer? If I do it correctly, no. There's no reason the next person should have their answer affected by the person I previously asked, especially if I pick them randomly. All right, so these two things are met. The 10% condition, you want to just make sure you don't grab too many people. We're grabbing about 1,000 people in each sample. That's way less than 10% of the U.S. population, so we're good. And the success-fail condition guarantees normality. We need it to be large enough. Basically, remember, the number of successes and failures have to be greater than or equal to 10. You need to show this calculation. So this is the number of people who said yes in 2007 and people who said no, people who said yes and people who said no. These are the successes, the ones who answered affirmatively, and these are the failures, the ones who answered negatively. Either way, all those numbers come out greater than or equal to 10, which means our sample size is large enough for a normal curve to be good. So since the normal curve is a good approximation of what's happening for the sampling distribution, we can perform a two proportion z-test, all right? So, and I'm stating what I'm doing, right? So this is the test that I wanted to do from the beginning. I'm able to do it because the conditions are met. Part 3 are the calculations. Now you can throw all this into a calculator if you know how to do it. If you put all this in the calculator, the only things they require you get are the z-score and the p-value. So you need these two things to get credit, which the calculator will give you. Just show you a little more of the mechanics. This would be the p-hat of 07. This is how many people answered yes in 07 and how many people answered yes in 08. It's about a 6% difference. Is that significant enough? People who answer this and don't understand it's asking for a test go, oh, look, yeah, 08's higher, so 08's higher, right? You know, everyone's higher, but it doesn't mean that, right? So these are from the samples. They could be coming from equal populations, and this is natural variation. So here's where I'm testing it. I go, well, here's the difference. The difference is about, 6%. If you're doing it by hand, you would need that pooled number. So the pooled number would be if you counted all the people who said yes out of all of the people who were surveyed. I don't know what those numbers are exactly, but it's roughly 1,300-ish out of 2,000-ish people, right? That pooled number is this. It's pooled, it's roughly 64%. You would use that to then get the standard error. The standard error is the pooled 1 and 2 P's and the pooled, I should say, let me be more precise. This would be P1, Q1 over N1, PQ, 2Q over N2. For P1 and P2 and Q1 and Q2, we're using the pooled number and the complement of this. So I use the 6397 in both of the P1s, and then 1 minus this, the leftover, is in the Qs. And then here's the sample size. That gives me the standard error of 0.0213. Then you get a z-score. So basically there's this difference of 6%. So when I subtracted these, I think I had it, according to my definition, 07 minus 08. So I had to get a negative number. When I subtract these, I get about negative 6%. How far is that from the hypothesized mean? Well, the hypothesized mean is 0. So I'm saying if there's really no difference, how often am I going to get a negative 6% difference? Well, the standard error is about 2%. So this z-score tells me that this value is out here at negative 2.82. So basically, how often will I get something like this or rarer? And since it's a two-sided test, I'm going to get this area in the calculator and then double it. And that comes out as 0.0048. Now, if you know how to use the calculator, you can just throw this data in and let it give you these two values. So we can skip that, but it's good to understand the concept of where it came from. Basically, what's the p-value tell me? It goes, if there really is no difference in the population, what is the chance I see a difference this large, basically 6% difference? Well, there's almost no chance that would happen, right? It's it's almost impossible that I would get this sample if the null were true. So basically that makes me conclude, well, the null probably isn't true, right? I mean, I don't know for sure, but I don't have, it seems like it's not good. So now I make my conclusion. The p-value is low. It's way under 0.05. It's actually less than 0.5%. So here I would just say due to low p-value, so this is part 4. Due to low p-value, I'm going to reject the null. So make sure you say that and then put it into context. What does it mean, context? It means that I have statistical evidence that the proportion of people who answered yes was different from 2008 to 2007. That looks like a 9, so let me make that look better. 2008 compared to 2007. Now, if I was writing this as a test, I would say a little more than this. I would say that, the difference in proportion of people who answered yes to the question about commercials being more effective and blah, blah, blah. But hopefully you get the idea. All right, so then how does the scoring work for this? Well, let's take a look at each of the parts. It's basically 4 parts, one for each part of the hypothesis test. So part 1 is the hypotheses. If you define your parameters, so you have to define like that mu sub 07, mu sub 08, what are you talking about, and then make the correct hypotheses, that gets you the E. If you do only one of the things, chances are you'd probably just make the hypotheses and not define them, you get a P. If you don't do either correctly, you get an I. Part 2 is the conditions check. So what they wanted to see, they want you to either say it's a two proportion z-test or perform one later. It's best to just say it outright. So there it is. Then the two major ones they want checked in this case, you check all of them, but they sometimes only focus on a couple of them, so the problem isn't too long for grading. They want you to somehow point out that it was random and to do the success-fail condition with the calculations. So if you do these three things, you get an E. You do 2 out of 3, you get the P. Otherwise, you don't get anything. 3, this is the test. So the actual calculations. They know you can do it in a calculator, so they only require the test statistic, which is the z-score, and the p-value. So once again, in my problem, a calculator would give me this and this. I could put those down, and that would be sufficient. If you do it by hand, you'll do more work, but you'll get them also. All right. So if you have the correct test statistic, once again, the z-score, the correct p-value, an E for both, a P if you only have one, or so if you put the p-value but don't put the z-score, they don't give you full credit. Let me see, get my reading. So 1 if the stat is wrong, but you have the correct p-value from it. So if you made some mistake but you got to the wrong test statistic, the wrong z-score, but you got a correct p-value from it, they let that slide. All right, and they also carry that through when you go to make your conclusion, they do base it on whatever p-value you came up with, even if it was wrong. All right, but basically that's the P, otherwise is the I, and then the ending, you need to make the correct decision. So you need to say, I'm going to reject the null. Unless you made a mistake up here, then they'll accept, so long as it was based on what you said. If you have it correct, you should make the correct decision as reject the null. You should give the context and link it to the p-value. So you should say, basically the way you cover this, like I did, would go, I'm going to reject the null hypothesis because the p-value is low, and then give what it means in the problem. That basically it means that there is a difference between the populations from 07 to 08. All right. Like with all four-part problems, each E is worth a point, each P is worth half a point, and each I is worth nothing. You basically can get half points if, remember, it's like 2.5. It's up to the grader whether they want to round up or down. So 2.5 would either go up to a 3 or go down to a 2 based on how strong they feel your answer is. All right. So this is a full-out hypothesis test, and they probably won't give you a full-out test, but this has all the concepts in it, right? All 4 parts, from making the hypotheses to checking conditions to calculating to conclusion. All right, so something that's good to know, because they'll probably ask you about many different parts of it. All right, so that was AP Practice Problem 10, and hopefully you'll go on and watch Problem 11.